students. In this class, I will be doing class 10 CBSE syllabus 6th chapter triangles exercise 6.4. Already I have completed 6 sums. Now 7th sum I will do. Prove that area of an equilateral triangle described on one side of a square is equal to the half the area of the equilateral triangle described on one of its diagonal. Okay, so prove that the area of an equilateral triangle described on one side of a square. So the base is square. So we are having a square. We'll name that square as ABCD. So ABCD is a square. Equilateral triangle. An area of, prove that the area of an equilateral triangle described on one side of a square. So this is a square. In this, an equilateral triangle is there. So we'll name this as PAD on one side of the square. Okay. Is equal to half the area of the equilateral triangle described on one of its diagonals. So we'll take AC as the diagonal. With AC as the diagonal, there is another equilateral triangle is drawn. Okay. So ABCD is a square. PAD is an equilateral triangle with the base as the side of the square, and AQC is another equilateral triangle with AC as that is the diagonal of the square is the base of that. So that is also an equilateral triangle. So we are asked to prove that area of an equilateral triangle, that is area of PAD described on one side of a square is equal to the, so area of PAD is equal to half the area of is equal to 1 by 2 into area of AQC. This is the thing we are asked to prove. Okay, so first we will write what are all the things given. So given is ABCD is a square. ABCD is a square. Then next one is PAD is an equilateral triangle with side with the length of side of a square. The length of the side of a square. Then next one is triangle AQC is an equilateral triangle with diagonal as its one side. With diagonal as one side. So these are all the things given. So we are asked to prove area of triangle PAD is equal to half the area of triangle AQC. Half the area of triangle AQC. So this is the thing we are asked to prove. So for proving this, we'll take the side of the square as A. So since the length of the sides of the square are equal, A is the side of the square. So if we need the length AC squared, according to Pythagoras theorem, we can write AC squared is equal to AB squared plus BC squared. So AB squared is A squared plus BC squared is also A squared. So we get it as 2A squared. AC squared is equal to 2A squared. So AC is equal to root 2A. AC is equal to root 2A. So we got the length of this as root 2A. Okay, we got the length of the equilateral triangle. For PAD, the equilateral triangle, the side is A. For AQC, the length of the equilateral triangle is root 2A. Okay, so we got AC length as root 2A. So now we'll take these two triangles, which is the thing we are asked to prove. PAD and AQC, those two triangles we'll take. So area of triangle PAD, area of triangle PAD by area of, we'll take that and prove. First we will take triangle PAD and triangle AQC. Already in the question it is given that they are equilateral triangle. So for an equilateral triangle, angles will be equal. So we can say that PAD is similar to triangle AQC by AA similarity. Okay, so triangle PAD is similar to triangle AQC. So in triangle PAD and triangle AQC, angles are equal. Angles are equal to 60 degree. So by AA similarity, we can say that these two triangles are similar. By AA similarity, these two triangles are similar. So since this is similar triangle, when we compare the area of these two similar triangles, that will be equal to the corresponding sides. That will be equal to the square of their, that will be equal to the ratio of the square of their corresponding sides. So area of triangle PAD by area of triangle AQC is equal to area of triangle PAD by area of triangle AQC is equal to AD squared by AC squared. So what is length of AD? Length of AD is A squared by what is length of AC? We got it as root 2A. AC squared is root 2A the whole square. So we get it as A squared by 2A squared. So when we cancel this A squared, we will get it as 1 by 2. So what is the thing we are asked to prove? Area of triangle PAD is equal to half the area of AQC. So that we got. So area of triangle PAD is equal to, when we cross multiply this area of triangle AQC, it will go to the other side. Already we have half there. So 1 by 2 into area of triangle AQC. Area of triangle AQC. So this is the thing we are asked to prove. So we have proved the result. Okay. Thank you.